What if our greatest engineer wasn't a person at all, but nature itself? Today, we're going to dive into ecological engineering, a field that's all about solving our biggest problems by learning from the planet's own blueprint. It's a huge question, right? It's so easy to feel swamped by all the headlines about environmental challenges. But really, behind all that noise, the most important question is, how do we actually build the solutions to these massive problems? And the scale of what we're facing is just immense. We're talking choked waterways, leveled forests, and this worrying silence in places that used to be buzzing with life. That's the reality we're up against. For a long, long time, our whole approach has been about conquering and controlling nature. But what if that mindset is actually part of the problem? What if there's a much smarter way to do things? Well, that's exactly where this new approach comes in. It's one that doesn't try to fight nature, but actually partners with it. Welcome to the world of ecological engineering. So what is it exactly? To put it simply, it's about designing sustainable systems where both people and the planet get something out of the deal. It's not about forcing our will on the environment. It's about finding that win-win. And when you compare it to how we usually do things, the difference is like night and day. On one hand, you've got conventional engineering, right? It often works against nature, relying on heavy chemicals and machinery. But on the other hand, ecological engineering works with nature. It uses natural processes to build systems that can basically run themselves. And get this, they don't just avoid harming biodiversity, they actively make it better. It's a total flip of the old script. So how does this all work in the real world? Well, it's not just random guesswork. There's a clear set of guiding principles, kind of like a rule book for how to design with nature. You can think of it as a four-part strategy. First, you tap into nature's own systems, the way it cycles nutrients and energy. Then, the goal is to design things that are self-sustaining, needing very little help from the outside. A huge piece of that puzzle is boosting biodiversity, because a more diverse system is a stronger, more resilient one. And finally, you power the whole thing with renewable resources. It's a complete, holistic blueprint. Okay, theory is great, but what does this actually look like on the ground? Let's check out a few real-world examples where these ideas are making a huge difference. All right, let's start with something pretty unglamorous but absolutely essential: wastewater. Our usual solution is to build these massive, energy-guzzling treatment plants. But there's another way. And nature's answer is just beautifully simple: constructed wetlands. These are basically engineered marshes that use all the natural processes of a real wetland to purify water. So here's how it works. The plants, the soil, the microbes, they all become this amazing living filter. They don't just trap pollutants, they actually consume them, breaking down harmful stuff and soaking up excess nutrients. And the result? It's not just cleaner water. You also get a brand new, thriving habitat. Let's look at another big one: food production, specifically fish farming. Industrial-scale aquaculture can be a really big source of pollution. So the ecological fix is something called integrated farming. Instead of just one species packed into a tank, you create a whole, balanced ecosystem in a pond. This means using organic fertilizers in something called polyculture, raising different species together that actually help each other out. When you manage the entire food web, you slash pollution, and you can even increase your total output. It's pretty amazing. This whole approach is also critical for healing land that's been damaged. And when it comes to restoration, engineers have two main tools. Passive restoration is kind of like first aid. You stop the source of the harm, and then you let nature take the lead to heal itself. Active restoration, though, that's more like surgery. It's very hands-on, replanting native vegetation, pulling out invasive species to really kickstart the recovery process. So when you pull all this together, what's the big payoff? What do we get from shifting our thinking in this direction? The benefits are just huge. We're talking cleaner water, healthier ecosystems, and more biodiversity. From an economic standpoint, it means we don't have to rely on expensive chemical treatments. But the biggest win, really, is resilience. We're creating systems that are stable and can take care of themselves for the long haul. Now let's be real. This isn't some kind of magic bullet. This kind of work requires a deep, deep understanding of ecology. These are living systems, so they take time to grow and mature. And yeah, the initial design and construction can sometimes cost more than the old school methods, even if they save a ton of money down the road. But in the end, it all comes back to this one incredibly powerful idea.
The goal isn't to build things in spite of nature. The goal is to design systems where we, human society, and the natural world can both thrive together. It's all about finding that mutual benefit.
And that leaves us with a final thought. For centuries, we've looked for innovation in our machines and in our labs. But what if the most sophisticated, most resilient, and most sustainable blueprint for our future has been all around us this entire time?